purpose of this video is for you to be able to use dimensional analysis and a scale to convert measurements. Crazy here is asking about the line. Crazy here questions why the line is so small when the circumference of the Earth is so big. Crazy here doesn't understand what Dr. Square means about it being to scale. Dr. Square basically tells him that it just represents the length. It isn't the true length. Because the true length is 24,000 or 25,000 square miles. Now, Dr. Square drew 4 other lines. Same length, but quantity of 4. And Crazy here wondered what there was a new scale. That would be 4 trips around the Earth. And yes, it would be. But the crazy part, and that's why Dr. Square was smiling, is these 4 lines also represent how long all of the blood vessels would be from an adult human if you connected them end to end. And this was how he explained what a scale was. But Crazy here didn't get it. So Dr. Square says, let's say I've got these 3 numbers. They're all something that have to do with the body. And he's going to square them to hopefully show how remarkable they are. So Dr. Square says, I'm going to just set 25,000 to equal 1 square. And then he's going to convert it. He's going to start with the 25,000. He puts his conversion factor on the bracket. And he always puts the like diagonal. Multiplies across, and he gets this 25,000 is equal to 1 square. And then he does something very similar with the other one. He draws his brackets, put the 10,000 here, 1 square over 25, multiplies across, divides the top by the bottom, and gets 4. And then he does the last one. This time he gets 92.6 because he started with 2 million and not just a smaller amount. Here comes the beauty of the example. If this is our scale, the 1 box represents how many breaths you take in a day. The 4 boxes represents how many heartbeats you have in a day. And the 92.6 represents how many red blood cells you make in a second. Now, whenever you make a scale, it's kind of simple. You just choose a scale, all right? And let's say this is my scale, and then you convert your measurements. And that's where dimensional analysis is going to help us. So here is our third example. Let's say I've got these 2 distances. 24,000 miles. It's roughly the Earth's circumference, and that's the other one's the distance to the moon. And we're going to scale them. So there's our scale. First thing we do, we put them on brackets, and we put our scalar factor on, like units diagonal, multiply across, and then divide. So the one is 2.4 centimeters, and the other one is 23.98 centimeters. So the distance to the moon is almost 24 boxes long, and the Earth's circumference is a little over 1. Now these may not be drawn exactly to 24 centimeters, but it's a scalar quantity. Here's another example. I'm just going to use random numbers that are actually real numbers, but I'll explain what they are later. If I had 17 to 181 micrometers, and I converted that to centimeters using this scale, that would be roughly 17 to 181 So 1.7 to 18.1 centimeters. And I remember I always put scale when I scale alike units diagonal. All right? This is the width of a human hair. The second one is the width of a human capillary. It's the small blood vessels in the body. They're smaller than your hair. So when I draw them, that's going to be 0.3 to 1 centimeter in length. And let's say I had 1,500 micrometers. That's this. I put it this scale factor, and that's going to give me 152 centimeters. Now that one was the penny width. That's the human capillary. It's between that long to that long. This is how wide human hairs are. That wide to that wide. And this is how wide the pennies would be if I put all those boxes together. This is wild. Look how much wider these things are than each other. No reason we have so many capillaries in our body, because they're so small. Now here's just another example of using dimensional analysis. Let's say these three continents, these three things: Finland, or Norway, New Hampshire, and Warner. This is how big they are in square miles. And the question is, how many of this in that? Well, this is how many Warners are in Norway. 2,660. It's a lot. And then how many New Hampshires are? How many Warners are in New Hampshire? 167. And the reason I was able to do that is with dimensional analysis.